Hello everyone. I'm going to create another image. This time it's going to be this image, which is, I don't know, like a galaxy with rainbow colors and stuff. Well, actually not rainbow colors because I don't see any yellow or deep blue or yeah. So I'm just going to try to recreate it in Canvas. So nothing too fancy in the HTML, just a canvas and things for this thing here below. I tried to say below and here at the same time that happened, yeah. Okay. And yeah, same thing goes with this CSS. You can pause the video if you want and look at that, but it won't be anything interesting. The interesting part will be in the JS. So let's get started. As always, get my canvas setup things. So seated with, where I see is the canvas. Okay. I want it to be full screen for now. Maybe later I'll change it along with the CSS. Seated with, which is equal to window in a width. Height equals seated height, which is equal to window in height. This should just make the canvas be full screen. Then we need to get the context. So you see that I got context of 2D. Okay, so now the basic canvas setup is done. I usually like to write down the options and parameters to the thing before doing anything else, so that I can really write the logics down and make sure that I don't change my mind over time and forget about stuff. So options. The first thing we need to do is actually look at the image. We can see that all we have is some particles going in some kind of ellipsoid orbit, which start at some place, get shiny when they're near the middle, and get less shiny until they die near the center. Also, we have some little other particles, which I think are like stars, and this is supposed to be a galaxy, which are just dots in there doing stuff. Okay. So we need to decide how many of them do we want. Let's say that we want. So I'll call the lines. So lines count. Let's say we want 30 of them at one time. We can change that later. I don't really care for now. I just want the thing to kind of work. And then we need to say how many of those little stars do we want. So star count is equal to again like 30. Not really important for now. Next thing is we need to define the shape of the ellipsoid. Yeah. So first of all, we need to give it a tilt, because if it was a normal ellipse, the thing would just be like this, but instead it's like this, so it's tilted by a very small value, I think. Like ellipse tilt is 0.1, that's the radians, I think. We'll change it later, I don't really care. Yeah, maybe like 0.3, I don't know. We need to give it a start x value. The particles actually start appearing at different places, like a little band of places. Not at just one ellipse, they start and they die at another location. It's actually a little worse than that. So ellipse axis S, axis, what was it? Axis, actually I can't remember. What am I doing with my life? So axis multiplier base x. So let me explain to you what's going on. Let's say that we have a basic radius of the ellipse. so which goes from the center to one of the sides. That is going to be a certain value. Actually, let's add it right now. Ellipse radius. Let's say that it's going to be like 200. So to make an ellipse, we need to multiply the radius by some value, again multiplied by the cosine of the gradient that we are in. And for the y-axis, we need to multiply the initial radius by the y multiplier by the sine of that gradient. Again, it might not really make much sense for now, but you'll see what I mean. Actually, this should, well, the axis multiplied by the radius should give the x-axis. This is the basic concept, but I wanted it to be a little, I don't know, more easy to write. So with the radius of that, we have the ellipse axis multiplier base x, which I don't know will be like, well, we know that the x is like 2 times as much as the y, so it should settle like at 1.8, and ellipse axis multiplier added x. This is what defines the band, well, the places in which the thing can spawn. I'm doing something really wrong right now. I'm not sure what I was saying. So let's say that we multiply the thing by the base, so we get like here. I hope you can see my cursor. I hope that the recorder is not moving it or something. But when we want to give it a random value, we want to add a random distance from the center to it, so that we can get a little bit more of a radius band thing, I don't know. So this means that it should the particles should start spawning at 1.8 and should well, and the farthest it can go is 2.2, because 1.8 plus 0.4 is 2.2. But again, that doesn't really feel clever at all. Yeah, there is something wrong, but I'll figure that out later, I think. So we need to do the same thing for the y-axis. This is just going to be like 0.9 and 0.2, half of the other thing. I really think that I should start thinking about what am I doing wrong, because otherwise. Okay, so let's say that the thing has a normal radius. No, because when we multiply by... No, okay, it's fine. This should be fine. You don't really know what's going on in my head right now, but I hope you understand later. Okay, so we have those little things. The next thing we need is a life parameter, I don't know, maybe? Or actually a speed for the lines. So line base speed, so we know that the speed should be perpendicular to its distance vector to the center, so that it kind of orbits, but not as perpendicular as you might think. So we need a constant for that, because we can see that none of the lines actually intersect, which means that actually the thing is constant. But that will have to be done before the axis tilting and multiplying thing, so we'll put that here. Again, for no particular reason, just because I want to get my logics written down before the actual logic itself. So we need a line so velocity tilt should be equal to like 0.1 or something, I don't know. Oh wait, actually let's say that we have the vector which goes down to the center. We then need to give it a velocity. Yeah, so we need like math.pi divided by 2 minus, so that it gets closer to the center. Whoa, what's going on here? I don't know what that was. Anyway, minus like 0.4. If we gave it a perpendicular velocity, it would just go in a perfect orbit if there is no friction. That's just how physics works. But if we do something like this, so velocity minus something, we should get a unstable orbit. Actually, to do that, we would need to well, this is mind-blowing, at least for me. We would actually need to add some friction to it. So with this thing, we get an ellipsoid thing, and with friction, which means actually decreasing the velocity, so we would get an acceleration. Okay, I know how to do this. Velocity field, okay, that's good. When we need line life, so line base life would be equal to, I don't know, like, well, let's say 40 frames. No, that's less than a second. We want something a bit slower, like 60. And then line added life, which is going to be like 20. So as the life decreases each frame, like let's say that a line is stuck with 60 life, or well, a value between 60 and 80, because that's 60 plus 20, its friction, so its velocity, well, which is kind of hard to explain actually. So to get gravitation going, we need to add to the velocity the distance, well, to the x of velocity, the distance from the point to the center in the x, and to the y, the distance from the point to the center in the y. But we don't want a stable orbit, so we want to add some friction to it, and the friction will be like, you know, that distance times the current life of the particle, which is actually being decremented every frame, divided by the original life. This way we kind of get like a smoothing function for the friction, which is exactly what we want, I think. Yeah, this way we shouldn't get a stable thing. Yeah, okay, this should work. Then added life, and this way you can also track the shine value of the object. Yeah. Okay, I'm gonna get a bit of a headache, but it's in my head, at least it's working. Next thing we need is the star things. So of course we need to give every star a life. So star base life, which should be something short like 10, and star added life should be again like 10. We just want some blinking stars. We don't want anything like permanent stars, because that's actually how stars are supposed to work. But yeah. Okay, so I think this is almost... Oh no, it isn't. We need just to specify the line base velocity to be something like, so 1 and line... No, they all need the same velocity. No, they don't, okay. Line, but they should have like very little difference between the velocities, so it's like 0.1. Okay. So now we need lines, an array of lines, an array of stars. We also need a tick count so that we can later change the hue of the things. So tick should... Whoops. Okay, wait a second. Yeah, strange stuff is happening. Like the stereo or something. I'll just change room. Should work. Okay, so we need the tick count, which for now is going to be 0, and that will just change the hue over time of each line particle. And I think that... No, also we need a first value. This is just to track down if it's the first time we call the animation function or not, so that we don't really do some stuff. Well, you'll see later again. So, function initialize. Yeah, so we need to reset the arrays containing all the particles. So lines.length is equal to stars, the length which is equal to 0. We need the tick can remain at any value really, we don't care. What else do we need? Okay, so we need a little repaint so that we don't get like those case. Yeah, again, this is hard to explain. So let's say that we have a really... also here I forgot to add repaint alpha. This would be something like 0.02. Let's say that we have like a rectangle in a canvas and we have a really low repaint alpha value. Yeah, the whole canvas will repaint, but where the rectangle has been, let's say that it was moving, for some alpha compositing issues, the canvas won't be able to get the places where the rectangle has been to be the same color as the rest of the background. Yeah, if you have worked with canvas before, you know what I'm talking about. So cdx.fill style is equal to this thing, and cdx.fill rect 0, 0 width and height. Actually, to be fair, instead of defining the... Yeah, okay. No, I don't know. What am I doing with my life? Yeah. How haven't I thought of this before? Okay, so my doubt was, should I have the... okay, so now I need to change other stuff right here. Ooh, and just multiply x for 2 and ellipse axis multiplier y is equal to 1. So if I should just have the ellipse be a result of the canvas transforms and rotations and stuff, or actually store the values of the particles in memory as canvas things. my thought is actually that it should be done by the canvas itself, so that it's a bit easier for us and I don't have to go through complicated maps because I don't want to. Ellipse base radius, this then becomes, and ellipse added radius is equal to like 40. This is actually in pixels, so we're fine, cool with that. Yeah. So f is the first time I call the init function. I start the loop, and I set the first value to false because then it won't be the first time again. So then we have to define the loop, of course. This will be very simple, so window.request animation frame of loop, and then we step or update, and we draw or render. It really depends on how do you prefer it to be. Okay, so now we have to actually define the step function and the draw function. Again, those should not be too hard to do at all, but yeah. Function step, all we're doing here is spawning new stars and lines, and let the constructors do the rest of the stepping, I think. Yeah. Okay, so if lines.length is less than opt.line_count, lines.push new line. Same thing for the stars. If stars.length is less than then opt.star count stars.push new star. Okay, so now we just iterate with that map through the line. So lines.map function of line.step, yeah, let me actually get this a little bit bigger so that I can see better what I'm doing. And we do the same thing with the stars. So stars.map function of star star.step. Yeah, so we have this. Actually, I think that the recording has been going on for more than 20 minutes, so it should be safe for me to just stop the recording here, and I'll take care of the rest in the next episode, because the logics are already laid down. All I need to do is actually write them. If you want to see me write them, yeah, see you there. Bye.